So this is one example. So I will give you something similar in the exam. So in your exam for constraint satisfaction problem, either I will give something like coloring the map, right? The example that you had with coloring the map of Australia, forward checking our consistency, something like that. Or I will give you example like this, which is, for example, class scheduling. Or I will give you example with numbers, like the example I solved, I think, last session. For example, I explicitly say this is A with 1, 2, 3, and then B could be, I don't know, 1, 2, C, 1, 2, 3. That is, I give you the variables A, B, C and their domains, and I give you some constraints. For example, A not equal to B, B less than C, something like that. And then I ask you to do arc consistency, okay? And I already solved that problem for you, so I'm going to provide another different example. Let's say you're responsible for assigning classroom to 5 courses that run on the same weekday. Now, the university has 3 available rooms for these 5 courses, and so these are the schedules of the courses. So your constraints are in terms of like the time. The time should not be like conflict each other. And then 2 classes cannot be assigned the same room if their times overlap. That's obvious, right? We cannot have like AI and DB at the same time in this room. And then, however, classes that do not overlap or they are not in the same time, they can be scheduled in the same room. And another condition is that this course, CS 104, requires special hardware and should be in room R2. Now, I will ask you in the exam, write it in like constraint satisfaction problem. It is what are the variables and their initial domains, and what are your constraints, or binary or unary constraints. And then showing how you can solve it using AC-3, okay? Now, let's see what are the variables here. The classes that we have, right? So CS 101, 102, these are your variables. And the domains are the rooms that we can assign to each course, right? So be careful. For all of them, you could assign the same domain. So all 3 rooms are available for all courses, except for this one, right? So for this one, we said that it needs a special equipment, so we only have to put it in room 2. Now, when you want to write the constraints, you write it in this way. So you look at here, we said that no 2 courses can be held in one room if they have like time conflict, they are at the same time. So for CS 101, what is this conflict? With 102, does it have overlaps? Right. Yes, it has. So we write it as a constraint here. CS 101 cannot be with the CS 102 because they have time conflict. And then what about CS 101 with 103? No overlaps, right? And with 104, no overlaps. With 105, no overlaps. Now go to CS 102. Which are the conflicts here? So it has conflict with 103, right? It has, because it's 9 to 10, and this one is 9:30 to 10:30, so they have overlap. 102 with 104? Yes or no? No. 103 with 102 started with 105? No. So again, for 102, there is only this constraint that cannot be with 103, right? In the same room. And the same way, you write it based on the time conflicts that you have. You, for example, check for CS 103 and then for CS 104, and then we're done, right? Now, as I mentioned before, I said if you have this constraint and you want to write your agenda or queue or whatever that you're sorting with, let's say queue, okay? So how do you add them to the queue? So you have to write the arcs in both directions. That is, this will be A not equal to B and B not equal to A. Similarly, this will be B less than 3, less than C, and C less than B, right? Or, yeah. So it's the same situation here. So you have to write all your arcs. For example, CS 101 and CS 102. you don't write only CS101, CS102. You have to also reverse it. That is CS102 and 101. And then you have to continue it the same way. That is, you write, for example, 102, 103, and then 103, 102, and so on. So this will be what you have in your queue, right? So you have 101 not equal to 102, right? And you also have to add the reverse of it, which is 102 not equal to 101. You had this constraint here, 102 not equal to 103. So you write this, and you also write the reverse, right? The third constraint is 103 not equal to 104. Again, not only you write this, but you also add the opposite way. That is 104 not equal to 103. And then finally the last one. Now, we are done with the domain, and so far you've got half of the point. So you have the domains, variables, and constraints and everything. Now we want to do the arc consistency. So what does arc consistency mean? It means when you have x and y, okay, and this is different if you write y to x, okay? So that is why we are checking both ways here. So when you check for this arc consistency, it means for every value in x domain, right, you want to see if there is a value in y such that it satisfies your constraint, okay? So for example, for a to b, it will be for each value in a, that is, if a is 1, if a is 2, if a is 3, for each value in a, you have to check if there is a value in b that satisfies the constraint at that stage that you are investigating. Like for example, if the constraint is a not equal to b, if you are checking this constraint in your queue, right? Now it said, if a is 1, is there a value in b that satisfies this constraint? Yes, it is, right? We have b2. So this is okay. Now, if a is 2, is there value in b such that a and b are not equal? Yes, because b can be 1. And if a is 3, yes, b can be 1 or 2. Now, you remove this constraint from the queue, but the domain of a has not changed, right? So you do not have to add anything to your queue so far. And so you go to the next constraint that you have on your queue. For example, the next constraint is now b not equal to a, right? Now, b not equal to a is different because now you have to check this one, right? For each value in b, you have to check if there is a value in a. So for each value in b means b is either 1 or 2 right now, right? The domain has not changed so far. So b is 1 or 2. Now let's say if b is 1, is there any value in a such that b and a are not equal? Yes. A could be 2 or 3. So this is fine. And then we continue the same way. So back to our example, I'm going to show you what you do when you reach to a conflict. So we start with our first constraint in the queue, right? So CS101 not equal to CS102. Now we should check each value in CS101, and we want to make sure for each value in the domain of CS101, there is at least one value in the domain of CS102 that satisfies this constraint, okay? Is there such value? So what are their domains? What is the domain of CS101? These are our domains, right? So it's R1, R2, R3. So is there, for example, if this is R1, do we have anything in R2 that satisfies the constraint that they are not equal? Yes. If this is R1, this could be R2 or R3, right? If this is R2, again, this satisfies, because then 102 could be R1 or R3. What if CS101 is R3? Again, the same. It's okay, because then 102 has still some options, could be R1 or R2. So here, all values are okay, and no change is needed. The same way is, for example, if you check for CS102 and 101. Now you check the domain of 102 this time, okay? Now, like in this example, the domain of 102 happened to be equal to the domain of 101. In your exam, may not be the same, right? Now you check here. If you give 102 R1, if you assign room 1 to this course, is there any value for this course that satisfies the constraint that these two are not in the same room? Yes. You could have 101 in room 2 or 3. The same way you continue for other values in 102, right? So you always check from the left one, right? And then you have to change the domain of the left one if needed. And then the same way you check for 102 and 103 until here. So I want to explain this one because then this is when you reach to a conflict. Now we are checking the domain of 103 and 104. So if you remember here, the domain of 104 is only room 2, right? Now we want to check when I check this constraint, what does it mean? It means for each value in 103, in the domain of 103, we want to check if there is a valid value in 104, right? Now, 103 could be room 1, room 2, or room 3. Let's say this is room 1. Do we have a valid value for this one? Yes, room 2. Let's say CS103, CS103 is room 2. Do we have a valid value for this one? No, because this is assigned to room 2. We said that the only room that can be used for this course is room 2, right? Therefore, this is a conflict here. Now, we have to remove R2 from the domain of this one because this is assigned to R2. We cannot have this one in R2. And so the domain is going to be changed. And this is important. Whenever you reach to a point where you have to change the domain of something, like for example, change the domain here, then you have to add all those arcs that have this one on the right side back to the queue. What does that mean? So if you have any constraint that have this course on the right side of the constraint, should be back to the queue. What is that constraint that should be back to the queue? This one, right? This one has 103 on the right side, right? And another point, each constraint that you check, after you check, you remove it from the queue, right? It's like you processed it, similar to the same way that we did with the search, right? We always, when we process a node, we said, okay, we visited, and then we removed it from the queue. This is the same. So for example, we checked all the constraints here. Everything was okay. Nothing was removed. And then we removed this from the queue. Next, we remove this one from the queue. Next, we remove this one from the queue, and this one, and this one. Now, when we reach this one, it tells us, because the domain of this has changed, you have to add it back to the queue. So now you have to add these two courses back to the queue. It happens that this one is already in the queue, right? So you only have to get back this one, add this one back. Now, let's check 104 with 103. The same way, you check the domain of 104, which is only room 2, and then you say if 104 is room 2, do we have any options for 103? Yes, 103 domain was R1 and R3, right? Both of them are okay. The same way you continue, again, another conflict arises here. So between 105 and 104, when you check, there is a conflict. Because the domain of 105 has changed, you have to add any constraint that has 105 in the right side. Okay? What are the constraints that have 105 in the right side? This is one that we just removed, right? Is there anything else? No. So you have to add this one, add this constraint to the queue again. So you have to process it again. So you add it back to the end of the queue, right? So these are the only constraints left. Then you check everything is okay. And when do you finish? When your queue is empty, right? So here, this is your queue. So if it is easier for you to understand, after you process each of these constraints, then put like underline here or something, okay? So for example, after step 1, this is removed from the queue. After step 2, this is also removed from the queue, right? After step 3, again, this is removed from the queue, right? Step 4, this is removed. And then step 5, I want to show you what happens. So this is also removed. And now step 5, when we remove it, there was a conflict, and we said that we have to add these nodes back to the queue, right? So this one, 102, 103, this one is getting back again to the queue, right? So that's the way that we process. It's very easy. Do you have any question? And after you do the arc consistency is not a search or algorithm that gives you a solution, right? It is just reducing your problem domains. So when you reach to that position, you still may need to, if I ask you to solve the problem, you still have to do, for example, backtracking to complete it.